Hello, good day, students. Today we are going to look at the overview of what we tend to cover in this course, data mining and big data analysis. In lecture 1, we will review the overview of data mining. What is data mining? We all know that is the process of discovering pattern and knowledge from large amounts of data. We look at different data mining tasks: classification, clustering, association rule, regression, and prediction. We will also see how we apply all these techniques in different applications like fraud detection, market basket analysis, healthcare, social media analysis, or sentiment analysis, house price prediction, and different applications where these techniques can be used to make a informed decision. We look at the key components. The data are in various variety, can be structured, unstructured, or semi-structured, just like information coming from social media, example Facebook. Knowledge discovering processes, how you can pre-process, cleaning, integration, selection. Tools, what are the tools that can be used to model this? We have Weka, RapidMiner, Python libraries. Here we are going to use Python programming language and use the different libraries that we can use to clean and model our data, such as sklearn, pandas, numpy, and others. We are going to make use of Jupyter Notebook. You can study or watch the first video I sent to you on how to use Jupyter Notebook in running your Python course. In lecture 2, we look at data warehousing and OLA, online analytical processing. What is data warehouse? It's a central repository for integrated data. It supports query and analysis. We look at different architecture, the data sources, ETL, extraction, transform, and load. These are the processes that are used in data warehouse. We can also use some front-end tools. We can just train a model using different data mining techniques. Then we can explore how we can use Django or Flask to deploy it in real time. Online analytical processing enables fast query performance. These are the different operations: roll up, break down, slicing, dicing. We look at real-world examples to read test sales analysis to identify trends. In lecture 2, we uh, review, as you all know, the big data characteristics. We know of the 5 V's: volume, velocity, variety, veracity, value. You all know what this means. Volume means that the big data is big, ranging from terabyte even to exabytes. Velocity is a speed, rapid speed at which this data occur, or this data is generated. Data from sensor, from IoT, from social media. Variety, different sources, different data sources can be structured, unstructured, or semi-structured. Veracity, the accuracy or reliability or quality of this data. The value has to do with the usefulness of this data in getting actionable insights. We look at big data tools, the Hadoop, HDFS, MapReduce, Apache Spark NoSQL databases. Challenges of big data in terms of scalability, storage, real-time processing. In our lecture 4, we look at data processing. You know, the raw data is usually noisy. How do we process it? Process it? The different data cleaning techniques, we are going to employ it, we're going to explore it, and we are going to practically use our Python codes to see how we clean a particular data set we are modeling. We are using to model our trend, our data. I will remove noise and inconsistency. There are different techniques of handling missing values, detecting outlier, data transformation, normalization, scaling. If your features are not in the same scale, you have to scale it using different data transformation. We have what we call dimensionality reduction. PCA is one of the techniques that we use in dimensionality reduction. Principal component analysis, the TSLE. Example, cleaning and normalizing a data set for customer segmentation. When you want to model a house prediction to model an application, you want to make a certain prediction that will be deployed in real time. The data set has to be cleaned. So we're going to explore all these things in our lecture 5. We look at data computation, multi-dimensional data analysis, data cube, multi-dimensional array of value, always online analytical processing operations. We practicalize all of them as I mentioned earlier. In our lecture 6, we look at mining frequent patterns, associations and correlations. Frequent pattern mining, the techniques like a priori algorithm, FP growth, association rule, the matrix, such as support confidence, correlation analysis, identifying relationship in data. We look at examples like market basket analysis to identify frequently purchased items. We are going to explore apply these techniques in different applications, which we are going to see practically, because when we use Python code to demonstrate this, we actually understand all these concepts. Lecture 2, we look at data classification methods. K means clustering, grouping data into K cluster. Hierarchical clustering, creating nested cluster. Density-based method, DPSCAN, for discovering arbitrary shape. We look at some use cases like customer segmentation, fraud detection, anomaly detection. We are going to explore additional resources and activities, hands-on exercises. I'm going to give you different exercises, giving you clue and resources to use it. You can also make use of my book in Python for data analysis and machine learning. There are different exercises there and case studies that describe a step-by-step method of training a model. You can also use any online resources available, but most of these things we're going to demonstrate it in the course of this class. We use Python libraries. There are other tools that we can use, but here I find it easier for us to use because there are many Python libraries that can help us do anything we want to do. We can also read materials, research papers, case studies, and textbook that people have published on different case studies where all these techniques are being really practicalized. We have weekly assignments to enable us understand these things fast. So you can also get, you can use my videos and or other videos online to help yourself in understanding this. By the grace of God, we're going to do justice to this course. And as time goes on, when we go deeply in each of the lectures, I will try my best to demonstrate this in practically. When you watch the first video I sent to you, you know the reason why I say in learning for beginners or in learning processes or even for advanced data analysis and modeling, I prefer using Jupyter Notebook. A watch of that video will show you the reason why I prefer using Jupyter Notebook, unless when our data is bigger than what our machine can carry. We can leverage cloud computing resources like Colab that can give us free access. And some people who are very good in cloud can also leverage AWS or Microsoft Azure. These ones require some payment, which we might not be able to afford. Thank you for listening.